Welcome. So in this lesson, we're going to be talking about using matrices to solve systems of linear equations. Now, before we launch into all of these notes here, I just want to take a moment to go through a background example, just to give us some context as to what exactly is going on. So you don't need to write this down. I just want to work it through together. I just want you to sit back, relax, and just take it in, because I think after going through this example, you'll just have a better idea of what we're doing. Okay, this example is also taken from Edrollo, the Edrollo Lesson 7G. So if you want to, you can also watch the nice person on Edrollo do this same example. All right, but let's now work through this together. Sit back, relax, don't write anything down. Let's go through this example. It says, at Hillsville Sanctuary, there is an enclosure that has wombats and emus in it. My son said that he counted altogether 15 heads. And my daughter said there were 46 legs. How many wombats and emus are there? Okay. So let's think about this for a moment. Now, hopefully you know this. A wombat has one head and an emu has one head. So if there are 15 heads in total, that means, altogether, when you count up the amount of wombats and emus and add them together, there are going to be 15 of those animals. So let's write an equation that kind of tells us that. So I'm going to say if I take all my wombats and I add them together with all my emus, that's going to be 15. Now, we can also write another equation from this, and that is there are 46 legs altogether. Now, how many legs does a wombat have? A wombat has 4 legs. How many legs does an emu have? An emu has 2 legs. So if I want to create an equation that represents this information, I'm going to say, well, it's 4 times the amount of wombats plus 2 times the amount of emus that will give us the total amount of legs, which is 46. So now we've created 2 equations that represents the information here. And now what we want to do is we want to find, well, what does W have to be and what does E have to be to satisfy both of these equations? Now, we're going to be solving this using matrices. But before we do that, I think it's important to visualize what exactly we're doing here. So again, here it is. You don't have to write this down in any way. I just want you paying attention. So here's just a visual of what we've just spoken about. So our red line here represents W plus E is equal to 15. And as you can see, my x-axis is the amount of wombats I have, and my y-axis is the amount of emus that I have. Okay, so if we think about this for a second, let's take a point on this line. Let's take this point right here. This is saying that if I have 2 wombats, so I'll put a 2 into the W spot, I'm going to end up with 13 emus. So I'll put a 13 here. And sure enough, 2 plus 13 is what? It's 15. Or maybe I have 11 wombats. And I therefore have 4 emus. Well, what is 11 plus 4? It's 15. So as you can see, irrespective of what point you take on this red line, when you sum the 2 numbers, you're going to end up with 15. So that's how the red line works there. Let's look at the blue line now. So the blue line is the information about the legs. So 4 times W plus 2 times E is equal to 46. The same logic here applies. If I take a point, and let's take this point here, this is saying if I have 3 wombats, so I'll put a 3 into this spot, and I have 17 emus, that's going to end up with 4 3s are 12, plus 2 17s are 34, and when I add those together, it's going to be 46. So as you can see, it satisfies the equation. And that's going to happen for every point on this blue line. When you sub it into this rule, it's going to end up with 46 out. Perfect. All right, let's now just clear the board a little bit. And let me just come here. Let's take this point right here. So this 213 point, and let's just analyze it for a second. This 213 point. So this is saying when I have 2 wombats, I have 13 emus. Would you agree that if I took this point here and I subbed it in to this, it's not going to satisfy this equation. So let's try it. So if I put 2 into my wombats and I put 13 into my emus, that's 4 2s are 8 and 2 13s are 26. When I add those together, it is not 46. So what does that tell us? It tells us that, just because it's true on the red line doesn't mean it's true on the blue line. Now, the whole point of what we're trying to do now, so let me clear the board, is find a point at which my W and E satisfies both the red line and the blue line. So in other words, I can put in a W and E value that is true for both of these equations. And hopefully you can see where this would occur. It's going to occur when they intersect. So at this point right here, do you see when I put this point in, 8 and 7, it's true for both of these equations. And we can see this in action. If I have 8 wombats and 7 emus, that's equal to 15. And then over here, if I put an 8 into my wombats and a 7 into my emus, 4 8s are 32, plus 2 7s are 14, that is equal to 46. So we have just found our answer. So our answer to this is going to be the amount of wombats is going to be 8, and the amount of emus is going to be 7. That's the answer. W is equal to 8, and E is equal to 7. That satisfies both of our equations, this one and this one. So that's how you think this question through graphically. Now, we don't want to do it graphically. What we want to do is to solve it with matrices. So now we're going to talk about how we're going to solve this with matrices now. Okay, so what are we going to do here? Well, let's begin by creating some matrices here. Into our first matrix here, what we're going to put is the coefficient of all of our letters here. So remember, the number in front of W here is going to be 1, and the number in front of E here is going to be 1. So this is going to be 1, 1. This will be 4, 2. So hopefully you can see what I've done here. I've just taken all these numbers and put them there. Then our next matrix is going to be a 2 by 1 matrix here. And this is going to be where I put my letters. So I'm going to put, and I'll do this in black here, I'm going to put W and then E. Now the order of that is important, and we'll talk about why we did it in that order soon. And then we're going to go is equal to this bracket, this bracket. It's going to be 15 here and 46 there. We have just created our matrix that represents this equation here. Now, if you're thinking to yourself, how exactly does this work? Well, this is where you've got to think about matrix multiplication for a second. So let's think about it. Remember, this right here is telling me I'm taking this row and I'm multiplying it with this column, right? That's what it's saying. So if I was to do that, that means I'm going 1 times W, which is 1W, plus 1 times E, 1 times E. And then, once you've done that, you're then going to say, all right, now I'm going to multiply this row by this column. And what's that going to get me? Well, that's going to get me 4 times W, 4W, plus 2 times E, 2E. And this is going to be equal to 1546. And hopefully you can see that this right here is the same as what we started with, wasn't it? 1W plus 1E is equal to 15, 4W plus 2E is equal to 46. So that's how that multiplication there is working and why these matrices represent these equations here. So hopefully that makes sense. Now let me just clear the board here for a second. Clearing the board. This is always the trickiest part. Oh, well done. Look at that. Look at this. That was flawless. Oh, no, I accidentally got rid of a 4 there. Okay. The next thing we're going to do is we're just going to label this. We're going to call this matrix A. We're going to call this matrix X. And we're going to call this matrix B. Now, what I want to do is I want to find what X is equal to. I want to figure out what W and E are. Now, to do that, we're going to use our knowledge of inverse matrices. So if I want this X by itself, that means I want to get rid of this A. To get rid of the A, what I'm going to do is multiply it by its inverse, because I know that if I do that, this whole thing just becomes an identity matrix. It just goes to 1. And that means I would be left with just the X. But whatever you do to one side, you must do to the other side. So I must also multiply this by the inverse of A. So what that is going to mean is that WE, so my X, is going to be equal to A inverse multiplied by B. And if I do that, I am going to get my answer. So let's now see this in action and see if it actually works. So let's come over here and we'll begin by defining some matrices for ourselves. We'll come here. We'll go 1, 1, 4, 2. control this, we'll define that as A. And then I need to define B. So I'll come over here. It's a 2 by 1. This will be 15 and 16. Sorry, 15 and 46. My goodness. Then I'm going to say, all right, control this is B. Hit enter. And now what I want to do is I want to take A. I want to take the inverse of it, -1, and I want to multiply it by B. And if I'm correct, I should get out W is 8 and E is 7. Drum roll, please. Look at that, 8 and 7. So that means if we come over here, we could write this as, my X matrix here, which is W and E, is equal to 8 and 7. So therefore, W is equal to 8 and E is equal to 7. Now that is just a background of what we're going to be doing in this lesson. So again, you didn't have to write any of that down, but I feel it's important to give us a bit of context as to what we're doing before we launch into it. So with that being said, let's now launch into the lesson.